Thank you. I'm good. Audible? Yeah. So yeah, thanks a lot for coming. Lorna kind of took some of my intro about, thank you for the last session, best for last and all that. But yeah, the one thing I will take is, it's just me between you and a beer. So please hang on tight. I want to get out of the way. So yeah, my name's Zach Burns. I'm a solutions architect on the startup team. And today, along with Rebrandly, we'll be talking about DynamoDB and how you can really hammer it at a big scale and do some cool things with it. So before we jump in, it's always good to take a step back and reflect on really the scale in which many of us operate applications at. And the upper echelon of these applications are what we call internet scale applications. And the types of internet scale applications that we typically see today are things like e-commerce applications like Amazon, eBay, media streaming like Netflix, Spotify, Apple Music, things like that. Social media, TikTok, X, Facebook, and of course, online gaming, which is a really growing sector. Fortnite, Epic Games, they really took off over the last few years. When we think of the characteristics that make up these internet scale applications, the users are typically well into the millions, right? Multi-million users, even billions of users on platforms like Facebook. The data they serve, well into the terabytes, even petabytes, huge scale, even exabytes. Locality, typically these customers are not just in one area, they're in every corner of the globe. And even with how spread out they are, they typically still demand millisecond latency response times. With all this many customers, you can typically expect millions and millions of requests per second, so you need to build a tolerant application to that. And the devices in which they use to access your application are never a single device, right? It can be a phone, it can be a tablet, a laptop, smart TV, even a watch. So yeah, cater to that. One thing we've really taken for granted in this day and age of cloud is elasticity. We want to make sure that our internet scale applications can serve that peak traffic, but we also want to make sure that they can come back down and serve the regular traffic patterns. Of course, again, from the cloud economics, we want to make sure that we're not guessing capacity, we're not buying up front. We want to do that pay-per-use model. We only pay for our resources when our customers are using them. And finally, if we have other parties consuming our applications, we want to make sure they have an instant and seamless developer experience consuming our APIs. And we really think of what is the backbone of these applications. It is typically the database. And today, we're obviously going to be focusing on DynamoDB and how that can really enable massive scale of applications. So one of the blogs that I look forward to the most every year is the kind of post-Amazon Prime Day release blog where they go into all the details of what services were used as part of Prime and how hard they were hit and how hard you can push them. And the one from 2024 was just released a few months ago. And some of the information that I pulled out from this was that they actually, over the course of the Prime Day event, tens of trillions of API requests were handled by DynamoDB. And again, if you've read these blogs before, you'll know that DynamoDB is a critical component of the Amazon infrastructure. So yeah, tens of trillions in a single day. It's kind of crazy. And of that tens of trillions, the peak traffic was 146 million requests in a single second. And that video was live footage of the on-call that day. Wasn't worrying at all, completely chilling. Yeah, DynamoDB, got it. Some other cool information about DynamoDB. We have over 1 million plus active customers currently using DynamoDB. And there are a few outliers of customers that really push this as hard as you can go. Some customers have single tables with more than 200 terabytes of data. And of these large customers, many of them are consuming capacity of well over 500,000 requests per second. And this equates to well over 1 billion requests in a month. Again, crazy scale. So one component of, like I said, modern day applications is elasticity. And the premise of what goes up must come down. It's all well and good being able to serve that peak traffic, but you need to come down and to a baseline that makes economical sense. So this graph is from a media company that was covering the Super Bowl. And you see that they had a large spike in traffic. So this could have been the halftime media show. People could have wrote a lot of opinions. But the premise here is that they configured a baseline write capacity units of about 5.7 million. And you can see that they're not quite using those capacity units. And what's good about DynamoDB is that if you're not using these capacity, they'll put it in essentially, you can think of a bucket that's like a moving scale. And this allows you to essentially grab into that bucket to burst above your provision capacity and serve that upper echelon of requests. So if you're a platform engineer, infrastructure engineer, and you're concerned that maybe we might have a big busy event, can our traffic or our database handle this? With DynamoDB, you can be sure that you can scale to meet those upper needs. Again, as long as your AWS account limits permit that level of access. So we've talked about the highs, consistent traffic, but whatever the pattern is, we want to make sure that we have a consistent performance to our end customers. We don't want to kind of hit that moment of fame where we get all our traffic and then things fall over, slow down. The vast majority of our customers would just leave the platform. But if you'll notice with DynamoDB, actually the more we hit it, the more reads we throw at it, the latency actually starts to decrease. It's not what you'd expect when throwing a lot of volume at a database. If we think of traditional SQL, we scale the memory, we scale the network, we have a lot more active connections, it starts to creak, it starts to slow down, and it'll eventually fall over. Not with DynamoDB, it actually gets better the harder we hit it. And so how do they do that? Well, it's the basic premise of scaling horizontally, right? You need to design data in a way that you can scale horizontally and not vertically. Again, it's the laws of physics. Vertical scaling can only go so far. If you design a data model that can go horizontally, that's where you get that equal performance and consistent performance. If you are interested in doing a deep dive on how the DynamoDB team actually build their infrastructure and their architecture, there's a really good YouTube video from a past reInvent that goes into the details. So just search, it's like deep dive on DynamoDB, and it's a really good 1-hour talk that goes into the weeds of that. I just wanted everyone to appreciate that animation. Yeah, so as I said, we have over 1 million customers using DynamoDB at the minute. So from the Expedias to the Tinders to the Amazons to startups on their day one. And in between, we have customers like Rebrandly who also use this in a very unique way. So I want to hand this over to Alex and Gonzalo to tell their story on how they use DynamoDB. Thank you.
Hello, hello. Oh, perfect, nice. All right. So, hi everyone. My name is Alex. I'm from Germany, from Berlin. So happy to present Rebrandly, our company. But before I will come to my pitch, please raise your hand who used at least once short link management platform or short links. Oh, nice, quite a lot of people. Thank you. Great. So yeah, so who is Rebrandly? Rebrandly, it's a world-class link management platform. So our community includes more than 100,000 developers. We have more than 103 million users. And these brands includes brands like Volvo, like Sequoia, Epic Games, and so on. Our platform has more than 1 billion plus active links. More than 3 billion clicks tracked monthly. And together with 99.99% uptime, this creates a really world-class management platform for us. Yes, and what I can tell more about us. Yeah, so what is short link? Yeah, so I see that a lot of people already know what is it. So, but here we have some short demo. What is it? So basically, from this ugly long link, you can create really nice short links. And our Rebrandly platform allows you to do this. So from our side, yeah, so we are creating more than 6 million unique short links per day. Yeah, and this is together with optimized UX, together with branded and trustworthy, together with dynamic data, and really great statistics and really great insights about link management. So coming to the technical side, yeah, so our technical stack includes data stores based on Amazon Elasticache, on Amazon DynamoDB, and so on. Yeah, so infrastructure includes Amazon Lambda, SageMaker, CloudFormation, and so on. So now I'm coming to this like really exciting story. Yeah, so how we were able to achieve 100,000 links per second. Coming to the story, yeah, so we have really great client who named WonderCave, and basically WonderCave used our solution to have really massive SMS campaign in US, yeah, to inform about disasters. I will come to the next slide and tell this more. So basically, our client used our solution to have massive informing about for our customers about hurricane and other disasters. Yeah, and I'm very proud that our Rebrandly, our platform, so used not only for marketing or for other stuff, but have really human value, to bring something valuable to the people. So happy to pass over to Gonzalo, our lead DevOps engineer. Thank you all.
Thank you, Alex. So the client requirements. So basically, when we start this, our clients try to explain us the goals that they need to achieve. So the challenge in the first time was get the requirements from the client, like how many links they need to create. In this case was just 100K per second. It's a huge amount. So the short link should point just to one URL destination. Obviously, the API response should be less than 10 seconds, but we achieved I did a spoiler alert. We did it in 1 second. So the back half, I don't know if you are familiar with this concept because it's too, I think it's not familiar because we use short link like a simple way to simplify. But the back half is like the path in a URL, yeah? So we have some constraints about you have to use only 6 characters because it's a SMS, you need to be short. So this can create some complication to us. Why? Because if you think about create a multiple massive amount of links, the simple solution can be system queue, like SQS. Wow, simple. Fast, but you can have some short link collisions because you are given a list for the clients, at least 100K links, but maybe it's not in the DB because you are using this short link for another destination. So it's like I will send you a party invitation and you go to the wrong address and say, where's the party? It's like, okay. So the second way for us was, okay, it's simple. We can just check if the link exists in the database and fix, but it's too slow and expensive, by the way. So we started to think, okay, how we can manage this because we cannot ask in the database in a fast way if the link exists or not. So, ta-da! Transaction API, and Golang. And this was, okay, we can create a massive amount of links because DynamoDB is super cool, is super fast, good. Transaction API was well. And we can use Golang to use a concurrency and at the same time the parallelism if the CPU is available. So we can go fast. All the people say, oh my gosh, this is good. We're creating a lot of short links in just 1 second, but in develop. Yes. So I don't know if you are familiar with this image, but this is a hot partition. This means that DynamoDB is struggling to save the data. So, but this is on production. We don't have the visibility in the development environment to see this. So obviously we are starting to cry. How we can fix this and why this is just in production and not in the development environment. Who knows? Yeah. Anyone can make a bet? Yes. This is the hot partition because in the production environment we have a global secondary index using a different partition key. The partition key in the global secondary index was the workspace. Every link is a unique partition, but belongs to the same workspace. So this creates a global secondary index, a hot partition. So, okay, how we can fix it? Simple, but have a trade-off that I can mention to you, that we are saving right now the workspace ID plus a random but controller partition from 0 to 9. So if you want to retrieve the data, you can make 10 parallel queries to DynamoDB and get all the results. It's a trade-off. But we solved the issue in production. So we closed the deal. So this is basically the product that we developed is Rebrandly embedded. It's basically a good tool to create a massive amount of short links. It's used in an SMS campaign. So it's the main components are three. The one is Golang, because it was super easy to use in terms of concurrency and parallelism, more than Node.js. Sorry if you love Node.js, but it is. Then you have the workers. The workers concept is about the writers in DynamoDB. In our case, we use ECS to deploy the workers. And finally, the DynamoDB. The DynamoDB for us is the sort of true about this link have this destination. This is basically the architecture. It's simplified, obviously. It's a bit more complex. But you can have an idea about how we can coordinate the request from the client. Then we split the request and create multiple tasks for every worker. And every worker can achieve a massive amount of insertion in DynamoDB. It's cool. I know. It's cool like this guy. So the principle is divide ad impera slatin. Yeah, I think we have both that can be more accurate with the sound. So divide and conquer, it's basically the principle that we use. And this is a Gopher, famous in Golang environments. So this is or one of the tests that we did. As you can see, even if we receive a massive concurrent request, we are below of 1.2 seconds. So in the peak, we are creating 5 million links in just 1.2 seconds. Wow, it's good or not? Let's go, come on. So results, we're happy with this because our solution launched basically in 13 business day. Was this I want to share with you because sometimes in the developer things, we are just worried about the code, but from our side, we can close deals with big clients, achieving these things, leverage with obviously with AWS to be fast and achieve these kind of things. So for now, 10 billion short links are generated via this API. And that's it. The group customer is valued by 10, so our stakeholders are happy. The life lessons. Okay, so this is a good idea to take some value from this presentation because the transaction API, in our case, I will try to be careful here, the transaction API was better for us because it's all or nothing transaction. So you don't need to worry about the retry if you are using the other batch item items. The DynamoDB in this case, it's the key part of the architecture. And finally, and for me, please follow the best practice when you design the partition key. This was the key for us because in develop all works good, but in production, no. Now, yes, because we fix it. So guys, if you want to more details, you can scan this code. Obviously, it's generated by Rebrandly, so it's working. You can take a photo as you want. And finally, you have another code, no bias. So please, thank you and enjoy the rest of the day.